is equal to cos n theta plus I sin n theta. Cos n theta plus I sin that, where n is an integer. N is an integer. 1 by cis theta is equal to cis minus theta. Second formula. 1 by cis theta is cis minus theta. For rational index, we'll look into it later. X is equal to cis theta. 1 by x is equal to cis minus theta. Then x plus 1 by x is 2 cos theta. X minus 1 by x is 2 I sin theta. X power n plus 1 by x power n is 2 cos n theta. X power n minus 1 by x power n is 2 I sin n theta. Right. Next. For exercise 2a, if n is an integer, then show that 1 by 1 minute. If n is an integer, then show that 1 plus I whole to the power of 2n plus 1 minus I whole to the power of 2n is equal to 2 power n plus 1 cos of n pi by 2. So what is 1 plus I? 1 plus I can be written as root 2 into 1 by root 2 plus I by root 2. 1 by root 2 plus I by root 2. So this 1 by root 2 can be written as cos pi by 4. And again 1 by root 2 can be written as sin pi by 4. So this is nothing but root 2 into cos pi by 4 plus I sin pi by 4. Right? And 1 plus I whole to the power of n. 1 plus I whole to the power of n is nothing but 1 plus I whole to the power of 2n I need. So this 1 plus I whole to the power of 2n is root 2 whole to the power of 2n into cos pi by 4 plus I sin pi by 4 whole to the power of 2n. This becomes 2 power n, root 2 and then 2 gets cancelled. 2 power n into, and the remaining part is cos n pi by 4 plus I sin 2n pi by 4 plus I sin 2n pi by 4. That's number 1. Similarly, 1 minus I can be written as root 2 into 1 by root 2 minus I by root 2. Okay. And then this can be written as root 2 into cos pi by 4, conjugate of the 1 plus I, so minus I sin pi by 4. 1 minus I whole to the power of 2n becomes root 2 whole to the power of n cos pi by 4 minus I sin pi by 4 whole to the power of 2n. This becomes 2 to the power of 2n. 2 to the power of n into cos n pi by 4, 2n pi by 4 minus I sin 2n pi by 4. That's number 2. Therefore, when you add 1 and 2, there is 1 plus I whole to the power of 2n plus 1 minus I whole to the power of 2n is equal to, when you take 2 power n common, then we remain with the 2 times of cos 2n pi by 4. And 2 gets cancelled here. Therefore, remaining is 2 power n plus 1 cos n pi by 4. The second problem, find the value of the following. 1 plus I whole to the I root 3 whole to the power of 3. We consider z as 1 plus I root 3 whole to the power of 3. 1 root 3. So I multiply and divide with 2 inside. 2 into 1 by 2 plus I root 3 by 2 whole to the power of 3. This becomes 2 cube. And this becomes cos pi by 6 pi by 3 plus I sin pi by 3 whole to the power of 3. There is nothing but 8 into, this is 6 pi by 3 whole cube. This can be written as 8 into 6 n theta 3 pi by 3. For 8 into 6 pi value is -1. For this becomes -8. Similarly, for second problem, consider z is equal to 1 minus I whole to the power of 8. This becomes multiply and divide with root 2. Root 2 into 1 by root 2 minus I by root 2 whole to the power of 8. This becomes 2 to the power of 4 into cos pi by 4 minus I sin pi by 4 whole to the power of 8. 2 power 4 into 6 minus pi by 4 whole to the power of 8. This 2 to the power of 4 into 6 minus 8 pi by 4. Since 2 pi is nothing but 0, since 0 is 1, therefore 2 power 4 into 1 is 16. If alpha, beta are roots of the complex number, then for any natural number n, show that alpha power n plus beta power n is equal to 2 power n plus 1 cos of n pi by 3. Alpha, beta are the roots of this equation. What is the given equation? Given x square minus 2x plus 4 is equal to 0. Roots are x is equal to minus b plus or minus root of b square minus 4ac is 16 by 2e. This becomes 1 plus or minus root of minus 3. It can be written as 1 plus or minus root 3i. Consider alpha is equal to 1 plus root 3i and beta is equal to 1 minus root 3. So this alpha can also be written as 2 into 1 by 2 plus I root 3 by 2. And this 1 minus root 3i can be written as 2 into 1 by 2 minus I root 3 by 2. So alpha is nothing but 2 into cos pi by 3 pi by 3 plus I sin pi by 3. That is 2 cis pi by 3. Similarly, b can be written as 2 into cos pi by 3 minus I sin pi by 3. There is nothing but 2 cis minus pi by 3. Now we'll move into this is not a and b, this is alpha and beta. So take LHS. LHS is alpha power n plus beta power n. What is alpha power n? 2 power n. Cis pi by 3 whole to the power of n becomes cis n pi by 3. And then 2 power n cis minus n pi by 3. Take 2 common, 2 power n. Cis n pi by 3 is cos n pi by 3 plus I sin n pi by 3. Cos pi by 3 plus I sin n pi by 3. Plus the cos n pi by 3 minus I sin n pi by 3. This minus I sin n pi by 3 plus I sin n pi by 3 gets cancelled. Remaining is 2 power n into 2 cos n pi by 3. So total it is 2 power n plus 1 cos of n pi by 3. Problem number 2, second problem. Cos alpha plus cos beta plus cos gamma equal to 0, which is equal to sin alpha plus sin beta plus sin gamma. Then we have to prove the following. And we have to prove this. So let us consider. So sigma cos alpha, that is cos alpha plus cos beta plus cos gamma. That is sigma cos alpha is equal to 0. And the next one what's given is sigma sin alpha equal to 0. Sigma cos alpha 0, sigma sin alpha 0. Let us consider A is equal to cis alpha. B is equal to cis beta. C is equal to cis gamma. We consider this. What is A plus B plus C? A plus B plus C is cis alpha plus cis beta plus cis gamma. Nothing but sigma cos alpha plus I into sigma sin alpha, which is equal to 0. Therefore, A plus this implies A plus B plus C is equal to 0. Isn't it? Cos alpha plus I sin alpha, cos beta plus I sin beta, cos gamma plus I sin gamma. Real part is sigma cos alpha, imaginary part is sigma sin alpha. This is first one. What is 1 by A plus 1 by B plus 1 by C? This is nothing but 1 by A means sigma sin cis minus alpha, and then cis minus beta, and then cis minus gamma. 1 by A, 1 by B, 1 by C. So there is a sigma cos alpha minus I into sigma sin alpha. This is nothing but 0. So which is ABC here, BC plus CA plus A, which implies BC plus CA plus AB is equal to 0. This is number 2. So we proved A plus B plus C is 0, and AB plus BC plus CA is equal to 0. When you square this, A square plus B square plus C square plus 2AB plus 2BC plus 2CA is equal to 0, since A plus B plus C equal to AB plus BC plus CA is equal to 0. This implies A square plus B square plus C square is equal to 0. This is number 3. Since A plus B plus C is equal to 0, in the earlier classes, we know that A cubed plus B cubed plus C cubed is equal to 3ABs. That's number 4. A plus B plus C 0, A cubed plus B cubed plus C cubed is equal to 3ABs. Now we have to prove the values of sigma cos 3 alpha is equal to 3 cos alpha plus beta plus gamma. Sigma sin 3 alpha is equal to 3 sin alpha plus beta plus gamma. And sigma cos of alpha plus beta is equal to 0. So we multiply like this. Since A cube plus B cube plus C cube is equal to 3ABC. Look here. A cube is nothing but cis alpha whole cube. B cube is nothing but cis beta whole cube. C cube is cis gamma whole cube is equal to 3 into cis alpha, cis beta, and cis gamma. Cis alpha whole cube is cis 3 alpha. Cis beta whole cube is cis 3 beta. And cis gamma whole cube is cis 3 gamma. Is equal to 3 times of cis alpha, cis beta, cis gamma is cis of alpha plus beta plus gamma. So here the real part is cos 3 alpha, here the real part is cos 3 beta, here the real part is cos 3 gamma. Since these two are complex numbers, comparing real parts, we get into cos 3 alpha, cos 3 beta, cos 3 gamma. You can write like this, plus I into sin 3 alpha plus sin 3 beta plus sin 3 gamma. This is equal to 3 cos alpha plus beta plus gamma into plus I into sin of alpha plus beta plus gamma. Now you compare, we'll get in the first one as answer, sigma cos 3 alpha. The real part is equal to 3 cos alpha plus beta plus gamma. So there is the first one. Similarly, sigma sin 3 alpha, the imaginary part, 3 sin alpha plus beta plus gamma. I think the first and the second problems have completed from the question. Okay. And we'll move into the since a plus b plus is equal to 0, since a plus b plus is equal to 0, since 1, a plus since AB plus BC plus A second is equal to 0. Taking this, A as cis alpha, B as cis beta, B as cis beta, and C as cis gamma, isn't it? Cis gamma, cis alpha is equal to 0. The cis alpha into cis beta is cis of alpha plus beta, and this as cis beta plus gamma, and this is cis gamma plus alpha is equal to 0. So here it is cos of alpha plus beta plus cos of beta plus gamma plus cos of gamma plus alpha plus I into sin of alpha plus beta, sin of beta plus gamma, sin of gamma plus alpha is equal to 0. So when you compare real part, you get into sigma cos of alpha plus beta is equal to 0. And when you compare imaginary part, sin of alpha plus beta is equal to 0. So look at the problem. Sigma cos alpha is equal to sigma sin alpha. We have to prove this. Before taking this, we consider ABC, A plus B plus C, AB plus BC plus CA, A square plus B square plus C square, and then A cubed plus B cubed plus C cubed is equal to 3ABC are the values. So when you consider this, then we'll get into sigma cos of 3 alpha is equal to 3 cos alpha plus beta plus gamma. When you compare AB, when you're taking AB plus BC plus CA equal to 0, we'll get in sigma cos of alpha plus beta is equal to 0. Right. Next. If Z is equal to cis theta, then we have to prove this. Next problem. Z is equal to cis theta. Means cos theta plus I sin theta. Z power n. Z power n is equal to cos n theta plus I sin n theta. I sin n theta. 1 by Z power n is cos n theta minus I sin n theta. Z power n plus 1 by Z power n is equal to 2 cos n theta. Okay. Z power n minus 1 by Z power n is equal to, subtract, we'll get into 2I sin n theta. And so this has 2, this has 3, this has 4. Divide 3 and 4. 4. There is Z power n minus 1 by Z power n by Z power n plus 1 by Z power n value. Nothing but 2I sin n theta by 2 cos n theta. 2 gets cancelled here. We're taking LCM. This becomes Z power 2n minus 1 by Z power 2n plus 1 is equal to I into tan n theta. This is problem number 4. Okay. Given 1 plus x whole to the power of n is equal to a0 plus a1x, a2x square, a3x cube, so on an x to the power of n. And we have to show that a0 minus a2 plus a4 minus 1 is equal to 2 power n by 2 cos of n pi by 4, and a1 minus a3 plus a5 minus 1 is equal to 2 power n by 2 sin of n pi by 4. Okay. But what's given is given 1 plus x whole to the power of n is equal to a0 plus a1x plus a2x square plus a3x cube, a4x to the power of 4, a5x to the power of 5, so on. When you consider x is equal to I, what happens? 1 plus I whole to the power of n. A naught plus a1 I square is minus 1, so minus a2. I cubed is minus I, a3 I power 4 is 1, a4 plus a5 so on. So if you consider the x is equal to minus I, this becomes 1 minus I whole to the power of n. This is equation number. This becomes a naught minus a1 minus I square is also minus a2 minus I cubed becomes plus a3 minus I to the power of 4 becomes 1, that is a4, and then in minus I whole to the power of 5 becomes minus I into I to the power of 4, that becomes minus a5 and then so on. This is number 2. When you add these two things, 1 plus I whole to the power of n plus 1 minus I whole to the power of n is equal to 2 times of a naught minus 2 times of a2 minus 2 times of plus 2 times of a4 and then minus so on. So 1 plus I whole to the power of n, 1 plus I whole to the power of n, this I can write it as root 2 into 1 by root 2 plus I by root 2 whole to the power of n, and then root 2 into 1 by root 2 minus I by root 2 whole to the power of n is equal to a naught 2 times of a naught minus a2 plus a4 so on. This is root 2 whole to the power of n. When I take common, root 2 whole to the power of n and cos pi by 4 plus I sin pi by 4 whole to the power of n plus root 2 whole to the power of n into cos pi by 4 minus I sin pi by 4 whole to the power of n is equal to 2 times of a naught minus a2 plus a4 so on. This 2 to the power of n by 2. Take this to this side, this by 2 into, I have taken root 2 whole to the power of n by 2 common, by 2 from this side. And the remaining is cos n pi by 4 plus I sin n pi by 4, isn't it? And then if you take this cos n pi by 4 minus I sin n pi by 4, simple problem, is equal to a naught minus a2 plus a4 minus so on. So these two gets cancelled. Remaining is 2 to the power of n by 2 cos of n pi by 4 is equal to a naught minus a2 plus a4 minus 1. Since 2 gets cancelled with the 2 cos n pi by 4. Similarly, since look here, there is 1 plus I whole to the power of n, there is 1 minus I whole to the power of n. Using this, I proved this. Similarly, when you subtract 1 plus I whole to the power of n, 1 minus I whole to the power of n, a naught gets cancelled, a1s, 2ia1, 2ia3, so on. I'll write this here. 1 plus I whole to the power of n minus 1 minus I whole to the power of n becomes 2ia1 minus 2ia3 plus 2ia5, so on. So this can be written as root 2 into 1 by root 2 plus I by root 2 whole to the power of n, and then minus root 2 into 1 by root 2 minus I by root 2 whole to the power of n is equal to 2I into a1 minus a3 plus a5, so this can be written as 2 to the power of n by 2 common. There is cos pi by 4 plus I sin pi by 4 whole to the power of n minus cos pi by 4 minus I sin pi by 4 whole to the power of n is equal to 2I into a1 minus a3 plus a5, so on. This is 2 power n by 2. I can write this as cos n pi by 4 plus I sin n pi by 4. There is minus cos n pi by 4 plus I sin n pi by 4. There is cos n pi by 4 minus I sin n pi by 4. And multiply with minus, we'll get this. Is equal to 2i into a1 minus a3 plus a5 minus so on. This becomes 2 power n by 2 into 2i sin n pi by 4 is equal to 2i into a1 minus a3 plus a5 minus so on. 2i gets cancelled. So remaining will be the answer. That's the important exercise 2a. There is exercise 2a of DEMOIVRES theorem. So we'll move into exercise 2b.